System of equations. Usually we are used to solve an equation in one variable, and when we have equations in two variables, in either linear ones or one linear and one quadratic or both quadratic, etc., we use system of equations to solve or to go to the solution. Now, checking the first equations. The first equations are both linear equations because if we check the degree, we have x to the first power and y to the first power. These two equations on a coordinate system will draw lines, both of these two. 4x minus 7y equal to 6 will draw a line, x plus 3y will draw a line. Then, by finding the solution, we check any possible intersection point. Now, for a linear, by the word line, we expect to have a straight line. So usually, in this type of equation, we will see either such a figure on the coordinate plane, so two lines intersecting. First case, we can see two parallel lines, never intersecting, never touching each other. We can also see the same line repeated two times. So this is the same line when we call the case when they are coincident. So the first case, when we have intersecting lines, this one, it means this system of equation will have exactly one solution. The second case, when the lines are parallel, we get no solution. No solution because we have no intersection point. It means that the lines are always far away from each other. They never cut, they never touch. And the third case is when they are coincident. We have here coincident lines we call exactly the same line. In this case, we will have infinitely many solutions. So we will have the same line indeed repeated two times. Checking our equation given here. We will try to find the solution by either elimination method. These are things we already are used to know. Elimination. Or either by substitution. So both ways, elimination or substitution, we'll go for finding the right point where the lines will be intersecting, or will show us if there is no solution at all, and then we will understand that the lines are parallel. Or in the last case, we will have infinitely many solutions, understanding that we are dealing with the same line. This is for linear, simultaneous linear equations, whereas here we have one straight line. If you look at this, here we draw such a line, similar, and the second line is a bented one. So we will have a shape like a parabola, even concave up or concave down. So we'll have such a shape, similar to this. In the second case, when we have one linear, one quadratic, we do not get one solution, no solution, or infinitely many solutions anymore, but we have the case when we have two solutions, one solution, or no solution at all. For the first case, when we have two solutions, we will have an intersecting line with a parabola at 2 points. So two pairs of points will be the solution for this system. When we have no one solution, we have the case when the parabola is tangent to the straight line, so they touch at only one point. And when we have no solution at all, the parabola will be far away from the straight line, and then they will never intersect or touch. So the general way how we deal with system of equations is if we have only linear equations, we use elimination or substitution. These are the main ways how to predict the solution and what to expect from the solution. To expect parallel lines, intersecting, or coincident. Whereas in the system of equations, if we try to use the elimination method, we will have difficulties eliminating any of the variables, because if I try, for example, to multiply by 3 the first equation, I will get 3x plus 3y equal to 9. Y's will be eliminated. X squared will be x squared plus x. It will be converted in a quadratic equation. So still we will go to solve for discriminant. If we use substitution, we may write y in terms of x and then substitute y on the second equation and go for solving for discriminant. So both ways will go to one type of solution, which is by substitution method. So we will substitute the variable here. So one quadratic and one linear equation is solved by substitution method. We will see solution for both. Starting with the first one, we have x plus 3y equal to 11. And then 4x minus 7y equal to 6. If I go for the solution by elimination method, I may try to multiply the first equation with 3, negative 4, sorry. So we may try to multiply the first equation by negative 4, and we will have for the first equation negative 4x minus 12y equal to negative 44. For the second equation, I have 4x minus 7y equal to 6. If I add this equation side by side, I will get negative 4x plus 4x, 0, negative 12x, negative 12y, negative 7y, negative 19y equal to negative 38. And then y will be negative 38 divided by negative 19, which is 2. I found the second coordinate of the intersection point. Now we can use substituting y in either of the equations, which is x plus 3 times one second. X plus 3 times y will be equal to 11. Instead of y, I write 2. I have x plus 3 times 2 equal to 11. And then I have x equal to 5. 11 minus 6, which is 5. So the solution point of these lines is first coordinate 5, second coordinate 2. They intersect at point 1, 2. These lines are intersecting. We are on a case of intersecting lines. So this is the point of intersection, the point 5, 2. and at the same time the solution of the system. If we go to one quadratic and one linear equation and try to find the solution, we have x plus y equal to 3. And also the second equation, which is x squared minus 3y equal to 1. Okay, so here we can try to multiply the first equation by positive 3 in this case, and write 3x plus 3y equal to 9. After that, add together with x squared minus 3y equal to 1. After we add step by step, we have x squared plus 3x equal to 10. Take 10 on the left, x squared plus 3x minus 10 equal to 0. We can find the solution by factorizing negative 10 into 5 and negative 3. Sorry, negative 2. And then x squared is x and x. We check by cross multiplying. Negative 2x plus 5x, we have 3x as a middle term. The factorization is correct. So after factorizing quadratic equation into x plus 5 and x minus 2, we have two roots. First root is x equal to negative 5, and second root is x2 equal to 2. After that, we need to substitute this point in order to find the respective y for each of them. So on the first or either on the second equation, we can use whatever we want from the equations to substitute x1. So if x1 is equal to negative 5, what will be the respective y1 for that? It will be negative 5 plus y equal to 3. Adding 5 on both sides, y1 will be 8. So this will be the point, negative 5 and 8. Checking the second solution for x2 equal to 2, I may substitute again on the first equation, and I have 2 plus y equal to 3. For that, I will find y equal to 1. So the second pair of points as a solution is the point 2, 1. Which means on this case of system of equations, we have one parabola and a straight line cutting at 2 points. So this is graphically the interpretation of the roots of the quadratic equation here. So taking the linear equation, substituting it into the quadratic one, finding the roots of the quadratic, we find these intersection points for the parabola and for the straight line. The first point is negative 5 and 8, and the second point of intersection is the point 2 and 1. Other ways how to check if we have solutions or not, after doing this substitution, after substituting the linear equation into the quadratic one, we can try to find discriminant. Discriminant is b squared minus 4ac, and if we check on this one, for a1, b3, 3 squared minus 4 times 1, and c negative 10, we will have 9 minus 4 times negative 10 plus 40, which 3 squared 9, which will have 49. Discriminant is positive. I expect to have two solutions. After substituting the linear equation, even without factorizing and finding the roots firstly, we can go directly for discriminant. And if discriminant is greater than 0, then it means yes, we have intersection points and we have two intersection points. But if discriminant is less than 0, it means that we will not have any intersection point. So So if we find a discriminant less than 0, it means the line and the parabola will not intersect. And if we have a discriminant equal to 0, the line and the parabola will intersect at one point. For this one, we will have a parabola far away from the line, not intersecting. And for this one, we will have a line touching at one point, which will be the tangent line to the parabola.